And so the same thing is true with exponential functions. The a that's multiplied by the b to the x is the vertical stretch or compression depending upon the size of a. The k is multiplied by x, so it's a horizontal stretch or compression depending upon the size of the k. The d is a horizontal translation depending upon the size of d, whether it's positive or negative. And the c is a vertical translation. And so it's the same transformations as in previous studies. And what that does graphically is it reflects the graph in the x-axis. And so y equals 3 to the x and y equals negative 3 to the x are reflections of each other in the x-axis. Notice that the 2 to the x plus 4 graph has been raised 4 units from the original y equals 2 to the x graph. For example, the 2 to the x graph goes through at 1 here, so the 2 to the x plus 4 graph goes through at 4 higher, or at 5 would be the y-intercept. It looks like they're getting closer together over here, but that's just because of the shape of the graph. There's still a vertical distance of 4 units straight up here between the graphs at any point.
We said, hey, if I have $100 and if I'm compounding at 10% a year, that's where this 1 comes from, how long does it take for me to double my money and end up with this equation? And to solve that equation, most calculators don't have a log base 1.1, and I've shown this in other videos. This, you could also say x is equal to log base 10 of 2 divided by log base 1.1 of 2. This is another way to calculate log base 1.1 of 2. I say this, oh sorry, this should be log base 10 of 1.1. And I say this because most calculators have a log base 10 function. And this are equivalent. And I've proven it in other videos. So in order to say how long does it take to double my money at 10% a year, you'd have to put that in your calculator. And let's try it out. Let's try it out right here. So we're going to have 2, and we're going to take the logarithm of that, which is 0.3, divided by, I'll do open parenthesis here just to be careful, divided by 1.1, and the logarithm of that, and we close the parentheses, is equal to 7.27 years, so roughly 7.3 years. So this is roughly equal to 7.3 years. And as we how long does it take for you to double your money? And that rule, this is called the rule of 72. Sometimes it's the rule of 70 or the rule of 69, but rule of 72 tends to be the most typical one, especially when you're talking about compounding over set periods of time, maybe not continuous compounding. Continuous compounding, you'll get closer to 69 or 70, but I'll show you what I mean in a second. So to answer that same question, so let's say I have 10% compounding annually, compounding annually, 10% interest compounding annually. Using the rule of 72, I say, how long does it take for me to double my money? I literally take 72. That's why it's called the rule of 72. I divide it by the percentage. So the percentage is 10. Its decimal representation is 0.1, but it's 10 per 100, percentage. So 72 divided by 10, and I get 7.2. It was annual, so 7.2 years. If this was 10% compounding monthly, it would be 7.2 months. So I got 7.2 years, which is pretty darn close to what we got by doing all of that fancy math.